Hello, everybody. Welcome back to the Engineered CM9892 Coding Bootcamp for FTC. In the past couple of videos, we have gone over basic mechanics of how our motors and servos and basic terminology function and how we use them. In today's video, we're going to be combining them all together in one file, or in other words, we're going to be using this under driver control, and we're also going to be explaining some more stuff as we go along. So again, we're using our previous skills and implementing them into current skills. So what I'm going to need everyone to do is go to FTC Robot Controller, Java, org.firstfire.ftc Robot Controller, go to External Samples, go to Basic Omni Op Mode Linear, and click on it. You're going to copy this file, and you're going to paste it into your team code. We will not be deleting all of the code in this file, but we will be making adjustments. And I'll be explaining what everything is in this specific file and why we're making the adjustments and what the purpose is. So again, I'm going to call mine driver control example. And that's what it's going to be called. Again, I'm going to delete all of this, the comments here. I'm going to delete all of this. Again, it's just the first line if you haven't opened it. It's just the first line, and mainly just so I get the package at the very top. Again, I'm going to delete all the comments, both for the @teleop, and just so there's nothing left. Again, it's all the /*, and that'll be all your comments. Now, I'm going to change the teleop or the driver control name to what the file is called. So again, I'm going to call it driver control example. And again, group linear op mode, you don't necessarily need this, but it is sometimes if things aren't showing up in the driver station, this is one thing you can add to make sure it does. Next, we're going to talk about this @disabled. @disabled basically means that the file won't show up in the driver station. So if you show this up and let's say you're testing a code, or you're writing a code, but you don't want it to be seen, but it's during competition, then you can add @disabled and the driver station will not see it. So, but there are two ways to get rid of it. You can comment it out using //, or you just flat out delete it. For this example, we're going to just delete the @disabled because we will be wanting to use our driver control. So now, again, public class, driver, or your file name, extends linear op mode. That's all good. And now we need to talk about private elapsed time. Now, this isn't used very much. It's only really used for a time-based autonomous, which we will not be doing for competitions. And it's also used for some telemetry. But telemetry on time isn't the biggest deal in the world. It doesn't really matter to us. So for this example, we will be getting rid of it. And note how there's going to be two errors up here. Do not worry about the errors. All of this will be fixed at the end of this video. And now you see the private DC motor. We're going to change all of these to motor FL, motor BL, motor FR, and motor BR. Motor BR. And basically all it is just so we know what motors goes to which, and especially since we're going to be changing things in the configuration, the driver station configuration, we want these to be matching what we're calling it in the driver station. So again, down here, we see in the @override public void run op mode, basically when the code is running, all the hardware maps have to be called. So now we're going to type in motor FL, motor BL, motor FR, and motor BR. And again, those are just the motor names up here that we're going to be putting down here. Next, we're going to have to change the driver station name for the motor. So again, I'm just going to call it whatever I have the motor named. So motor FL, motor BL, motor FR, motor BR. So again, this is just the basic drive code. Now, this is where things can get a little more annoying, and you will have to play with this. but it is the motor directions. Again, I'm going to get rid of these notes just because I'm going to explain it and try to make this a little simpler to understand. So every time you do motor directions, it will change the way the robot is orientated. Again, if we go back to the motor example here, you will see that I have this currently set to the forward direction of what my robot is. For example, last year we used a gear ratio for the motors. So this was the motor direction from last year. But let's say you're using something like direct drive. You're going to have to figure out what that is based on your robot that you're building for. And since you have to set the motor direction, you want them set to forward. And whatever that may look like. If that means the left side motors are reversed, so motor FL and motor BL are reversed, like this example here, and the right sides are forward, motor FR and motor BR are forward, that means your robot will go forward. Or you might just have to play around with it. At the end of the day, it may be a little annoying, but you might have to do that. So again, play around with this in case it isn't working. I would suggest doing a basic time-based op mode to test them, but you could always figure it out during your testing. So next, we're going to go to, this is just a telemetry. We've talked about this in the first video. The wait for start, waiting for the code to operate, and the runtime.reset. All we're going to do is we're just going to delete it. We are not going to worry about a runtime reset. Basically, it's the timer resetting itself. Now, let's get into the fun bits. The basically setting variables to buttons, or setting variables to buttons and being able to use it for our code. So this is just a pure driving code. I will be explaining how to add servos and motors in after this. But again, let's just talk about the driving right now. So right here, we have double max. Do not worry about this. I will explain this in a minute. Now, this right here, your gamepad 1 negative left stick, your gamepad 1 left stick X, and your gamepad 1 right stick X. The negative Y value is kind of, the top is -1, the bottom is 1. So that's why we put a negative value here. So basically, it's always acting as a positive. This right here is just the x-axis. The far right is 1. The far left is -1. So this one's fine. And this one is just basically so if we can make sharp rotations on the joystick. So yeah, this is the math for the wheels, or the power, sorry. I'm like, oh, hey, this is how much power I need to give the motor. And again, this does the absolute value of all the powers. And then this right here, if max is greater than 1, set the power to max. And again, what you're going to have to do at the bottom, I would get rid of this telemetry here, the runtime to string. You don't really need it. Pop. And all you have to do is change all this motor FL for the left front power, motor FR for the right front power, motor BR or BL, sorry, for back left power, and motor BR for back right power. And right now we have 0 errors, but I do want to talk about a couple more things, such as Boolean functions for motors and so on and so forth. And you don't need this. You can just get rid of this comment here. I wouldn't really worry about that. But now let's go up to the top, and I'm going to add a private DC motor. I'm going to call it test equals null. I'm also going to add one servo, so servo. And I have to import this, so I'm going to hit Alt Enter. Servo, I'm going to call it test2 or test servo equals null. All my values here are good. Just if it's a servo, just set it to null. If it's a DC motor, set it to null. Now, I'm going to have to call the hardware map of both of these. So I'm going to put in motor, or test, sorry, just test, equals hardware map dot get DC motor dot class, comma, quotation marks, this. And that's my motor. Now I have to do test servo equals hardware map dot servo dot get quotation marks. I'm going to call it test servo. And all it's doing is just setting the hardware maps for the two motors and / or servos that we set. And again, for this one, I would set the motor direction to forward. So test dot set direction. I'm just going to type in capital letters forward, and I can just do the autocomplete. So DC motor simple dot direction dot forward. Now I'm going to do the servo one as well. So servo dot set direction forward direction servo dot direction dot forward. Again, it's just so in case we do need to reverse it, we can. And now we're going to go down here. Now that we have the motor set, we're going to set this to a variable. So what I'm going to do is I'm going to do below the telemetry right here. I'm going to type an if statement, and I'm going to do parentheses gamepad 1.a. I'm going to do curly brackets. I'm going to enter it down. Now, all this does is basically saying, if I press A, this is what's going to happen. So I'm going to say test dot set power. That means that test is going to be set at 100% power. So like that motor that we're using for something else is going to be set at 100% power all the time while A is pressed. Now I'm going to set the servo dot set position. I'm going to set the 0.7. So I'm telling, if I hit the gamepad A, it's going to go to the power 1. So it's going to go to 100% power for the motor. And the servo is going to set to a position of 7. Now, I mean, that's really it for this video. I hope this was useful and enjoyable. But other than that, that's all. And I'll talk to you guys next time. All right. Bye-bye.